range of forecast or confidence interval. Again, we are using concepts from statistics. When we do confidence interval, there is another alpha. This is not the exponential smoothing alpha. They are not equal, which is called level of significance. Basically, 1 minus alpha is the confidence interval. Right. When we do the forecast and say next period forecast is 60, basically we are saying that the average number is 60, expected to be 60, but in reality the actual demand or sales we might observe could be higher or lower than that. So we would like to determine what could be the range of those numbers, and I'm going to use F lower and F upper, basically upper bound for the forecast and a lower bound for the forecast. When we say 95% confidence interval, for example, what we are saying is this area is equal to 0.95, right? That means the remaining two areas on the edge, they are equal because this normal distribution is symmetric, and they are gonna be alpha by 2. In that case, it is 0.25 and 0.25, right? What I need to do is, in order to get this F upper bound and F lower bound, read the Z value from the normal distribution table, right? And for Z value, depending on the table, I might be able to read this part or this part. If this part is the one I'm reading, then I'm gonna just basically read the 0.0 Z value corresponding to 0.025. If I'm reading the upper bound Z value, then I need to make sure that I understand that although this area is 0.95, there's an additional 0.025 there, so I need to read the Z value for 1 minus alpha by 2, right? So let's go do that one for our example of 95% confidence level. So the Z value is 1 minus 0.05 divided by 2. That means I'm going to read 975. So let me switch to a normal distribution table. What I need to do is look inside this table and read the 0.975, right? Luckily it is right here, right? And the corresponding Z value is 1.96. So my Z value is 1.96, right? Right? And F upper and lower bound are basically equal to Ft plus minus Z value times SF that we have calculated in earlier steps. So for that reason, I prefer calculating SF value rather than MAD values, because if you do the MAD, you have to calculate an SF value anyway to calculate the range. So my preferred forecasting error measure is SF for just that reason. So let's calculate the F lower bound, and that is gonna be 60 minus Z value of 196, and the SF value for the moving average, which was the first best method, 1504. So that turns out to be 30.5, right? And F upper bound is that 60 plus 1.96 times 1504, and that becomes 89 point basically 4 or 5. Let's round it as well. Okay. Let me use my awesome eraser. Right. So what we say is with 95% probability the actual demand is going to be between 30.5 and 89.5, right? With an expected value of 60. Now, what are the methods to basically improve our accuracy? First of all, we had only 4 data points. If we could add more data points, that would probably improve our forecast accuracy and hopefully reduce this range between these two numbers. Another one is this z value. So if I increase my confidence interval, by default the range is going to be larger. So instead of saying 95%, perhaps I can go to 90% confidence interval and reduce that range a little, but you gotta be very careful. And again, the final method is basically choosing the right forecasting method. We could do choose one of the others, and we will see that our range is gonna be higher than these for the reason that their SF value is larger, right? So those are the 3 methods that we could use.